Hey, Chris Guzmal here. We have implemented the Radix sort helper test number 3, which does indeed perform a Radix sort on the array SAT here on line 81. What we're going to do now is we're going to generalize this. It's still, well, we're going to generalize it and then we're going to encapsulate. In other words, we're going to do generalization and we're going to do abstraction. This is kind of a real basic exercise in distinguishing between, or at least illustrating, the two concepts. Generalization is going to be that we're going to assume SAT has not just 1 or 2 digits, but an arbitrary number of digits. And so we do extract digit SAT 0, extract digit of actual 1. Well, you know, could have I called this actual here at the beginning? I probably could have, or I could have done SAT equals counting sort with sat int. And in fact, let's try that out here. Let's do a small change in the direction of, see what I'm thinking faster than I'm talking. SAT is an array of integers. What I do then is a sequence of operations where I extract a digit, and then I do a counting sort using that extracted digit. And then, so lines 100 and 101 are almost identical to lines 102 and 103, okay? However, they're close enough, actually. I'm setting AR to a thing, I'm setting actual to a thing, and repeating. The one place there's a difference is I have SAT over here, and I would rather have actual here on line 101, and I think I can do that, and that's not that hard. Let me do it in Radix sort helpers test 3. This is the same code up here, and what all I'm going to do is I'm going to call SAT actual, and that means I'm going to call this SAT actual. And then, of course, that means I have duplicated actual, so I'm going to call actual, but not have to declare it. So those are all pretty modest changes, which ought not change anything in terms of my test run. Oh, wait, SAT, of course, is never used on line 82. I have it right there. I better change that to actual. I thought I caught all the examples, but that's why we actually run the code. So now, sure enough, Radix sort helpers test 3 has been modified slightly. A good version control system would keep track of that for me, and I don't have that, so it may come back to bite us later on that I made even that tiny little change. And of course, I have to track that change here as well. So I'm taking the chance that I don't make a mistake by making the exact same changes as I did a moment ago, but in a different place. And basically, SAT shouldn't exist anywhere. It should be actual. All right. The advantage of doing this little ledger domain is that now I have this pattern. AR equals extract digit, actual equals counting sort with sat int, AR equals extract digit, actual equals counting sort with sat int. And so that's something that I can now generalize. And this 0 here is a variable. It's an index, which I'll call D. Excuse me. I said I was thinking D, and let's make it D. Okay. So actual D. All right. That's about it, except for one little detail that, of course, AR exists prior, just in terms of declaration. Let's see if I can get away with this. See if the compiler complains about that. All right. And so now lines 102 and 103 are identical to lines 104 and 105, except of course here I have 1 instead of D, so I'll put D there as well. those changes make it so that 102 and 103 are identical to lines 104 and 105. But of course now that means that we've got to create we've got to parameterize, we've got to declare D for int. So this is our standard idiom. But now the question is, what does D go up to? D is not the size of some array. D is the length of the number of digits in the values in AR. Okay. So what should that value be? Well, the laziest choice, I suppose, is to choose a value and assume we have, say, 32 bits of precision to our digits, and 2 to the 32nd power is 4 billion, and so that's like 10 digits, right? So if I just do the first 10 digits, that should sort things just right fine. Now that's a lot more digits than we actually have here in actual, but that's okay, presumably. Let's see if when we run, we don't get a compiler error. We do not get a compiler error on RadizSort helpers test 4. Now we need to invoke RadizSort helpers test 4. So we do that here by copying RadizSort helpers test 3 and incrementing 3 to a 4. So now this generalization we're hoping works. It does. It gives us a pass on 13 iterations. I'm not completely comfortable about RadizSort helpers test 4 though, because it's doing a sort of the exact same kind of data as we had in our other examples. The good news is the loop does appear to work. That's fantastic, really. But for RadizSort helpers test 5, I need to have a more interesting set of values. So we'll do 888 and 1, 2, 3, 4 and 4, 3, 2, 1. That's not that much more, right? And of course, what is the expected value? Well, the 1, 2, 2, 4, 3, 1, 4, 1 are all going to be in the same place. But then we're going to have 888, 1, 2, 3, 4, 4, 3, 2, 1. Well, I'm not that psyched about that order because it's the same order as we had before. So I'm just going to put 4, 3, 2, 1, 888, 1, 2, 3, 4. So that should, let's see whether or not that successfully compiles. It does. And Radix test helper, whatever it is, number 5, the 5th of these, RadizSort helpers test 5, is kind of a full-blown test that, if it works, means that I'm ready to do encapsulation. It does work. We have 14 passes on all those tests, and so this now means that I am ready to take the code in RadizSort helper test 5 and use it to write the RadizSort in general. Okay. And so I'm going to copy that, copy the core code, and write my method here. I'm kind of in the middle of all these test cases, so my coding style is not ideal, but I like to be able to see my RadizSort helpers test 5 right there next to me. So this is a public static. Is it void? I don't think so. I'm thinking I'm going to return the sorted array. So it's going to be RadizSort. It's going to have some arguments. I don't remember what, but it's going to fundamentally do this code that I've copied. And so the input, I could pass actual. And the question is, do I need to pass anything else in? No, I don't think so. Okay. And note extract digit's going to generate the array that I need. So I guess I'm okay on that front. So actual is not a thing I need anymore. And I need to return. What am I going to return? I can return actual here. It's important to note that actual is mutable, and what's getting returned here is not what's passed in. Okay, that's kind of that kind of obscures some things. You know, I'm sort of debating whether or not to create a variable called retval, so it becomes clear that actual itself is not actually modified. But I will certainly say is not modified in this implementation, despite the return, despite what the return suggests. Okay. So again, let's see if our current code runs. It runs. RadixSort is not invoked. We need to implement RadixSort test 1, okay, which is going to be a lot like RadixSort helpers test 5. So we'll go ahead and take RadixSort helper test 5, copy it, return, modify this to RadixSort test. Our actual will be this input. I don't think we need AR anymore though. And instead what we can do is simply say actual equals. So now ironically we modify actual, modify what actual points to by invoking RadixSort on actual. Okay. And RadixSort test now should do the same. It is doing exactly the same thing as RadixSort helper tests, but we took the code right here from line 122 through 128, and we encapsulated inside. Actually, that's not true. 123 lines 123 to 128, and we encapsulate that into line 144, hiding all those details of how we do it. Now, the fact that we do it exactly the same way as RadixSort helper test 5 doesn't mean that we aren't hiding the details. We are still hiding the details, and that's effectively the purpose of creating the encapsulation represented by the RadixSort method invocation on line 144. The generalization from RadixSort helpers test 5, however, it has to pay attention to a lot of details. However, it works in a more general fashion than RadixSort helpers test 4. And that's sort of the difference between generalization and abstraction. Now that we successfully run, oh, you know what? I just noticed I called this 5. So let's find out whether or not we get an error when we invoke RadixSort helpers test 5. Oh my gosh, it does fail. 12, 24, 31, 41, 88, 120. 12, 24, 31, 41, 88. That looks correct. 888. Oh, my expected value. I have a mistake in the test code, almost certainly. You know, every single time there's a mistake. So I forgot to type in an extra 8 here. And that appears to be the source of my error. Exposed by immediately, I immediately am able to see and compare the expected to the actual. So the conventions that I've been using expose the errors that I make. And so that's you know, a validation of the process that I'm using here, that this process does expose, reveals the mistakes that I made. I very easily made that fix. Now it's going to be RadixSort test. And let's see whether or not the RadixSort test succeeds. It fails. And that's because I've propagated the mistake. And this, I was complaining about copying and pasting code that was identical. This is a perfect example of that. I'm now having to fix the exact same mistake as I made a moment ago. I just have to scroll down and find, oh my God, where is it? At some there is Radix sort test above or below this. I'm pretty sure. Oh, there it is. It's above this, and this 888 needs to be 88. Excuse me, needs to be an 888, not 878 and 888. So this exposes both the strengths and the weaknesses of my method. Sure enough, we have a pass for all 15 cases. And so our Radix sort has been tested in a relatively interesting test case, Radix sort test. And it's supported by all these other Radix sort helper method tests. So I actually have a high level of confidence that the Radix sort works in a fairly robust set of cases. There are obviously examples, for example, negative values. Oh my gosh, what's up with that? I guess I can't do a Radix sort on negative values right now. So, maybe I'll put a note there. But other than that, I'm pretty happy with our Radix sort. Negative values. And you can think about what you do in order to do a successful Radix sort on negative values.